So let's keep going on to the next example. We want to use a cosine sum or difference identity to find cosine of 345 degrees and the secant of 17 pi over 12. So what this is asking me to do is, obviously we don't have 345 degrees. That's not on our unit circle right now. That's, y'all know 300, 315, and 360, but you don't know 345. So what this problem is asking us to do is, let's break it down. Cosine of 345. We want to write it as either the sum of two angles that I know or the difference of two angles I know. Okay? We can't say it's 360 minus 15. So I know 360, but I don't know 15. So let's think of two other angles we might know. Well, I can think of cosine as I know 300 degrees, and I also know 45 degrees. Okay? So let's expand this out now. So the cosine of 300 degrees and 45 degrees is the cosine of 300 times the cosine of 45, opposite, so minus the sine of 300 degrees times the sine of 45 degrees. Okay? So just using our identity that we have, that we learned at the very beginning of this lesson. Okay. Alright, what is my x value at 300 degrees? Well, 300 degrees is just a little bit past 270, and it's down there in quadrant 4, so my x value is negative 1/2. My x value at 45 degrees is positive, because we're in quadrant 1, and at 45, or at pi over 4, so we're always the square root of 2 over 2. The y value at 300 degrees, we are down, at 300 degrees my x value should be positive, shouldn't it? Because we're in quadrant 4, we're to the right. My y value now should be negative. And down there, we're far down, so we're at square root of 3 over 2. And my y value at 45 degrees is square root of 2 over 2. Alright, so yeah, do what I do. Make sure you go back and double check, because we don't want to get the problem wrong just for a silly little sign thing. Let's multiply these two fractions together. Square root of 2 over 4 minus, change it to a plus because two negatives make plus, square root of 3 times the square root of 2 is the square root of 6, all over 4. And since we have a common denominator, we can write that as the square root of 2 plus the square root of 6, all over 4. And that's exactly how we can find, that's the benefit of knowing this identity. When we're wanting to find an angle that we don't know that's on the unit circle, let's take two that we do know that's on the unit circle, and then we can get it. And so coming back to really what this problem is saying is that if I had you guys memorize 345 degrees on the unit circle, in that coordinate, the x value in that coordinate would be this right here, and then some other y value right there. Isn't that crazy? Would you like to have that memorized? I think it's simpler just to remember things like 1/2 or the square root of 3 over 2. Looks a little bit easier. Okay, so let's go on. The second thing we need to do is we need to find the secant of 17 pi over 12. Well, the secant of 17 pi over 12, we don't have a formula for the secant. What we have, the formula is for the cosine, and secant is thus the reciprocal of cosine. Okay, well, again, on the unit circle, I don't know anything that deals with pi over 12. I know pi over 4, pi over 3, pi over 6, pi over 2, plain pi's, but I don't know pi over 12. So what we want to do is write the cosine of 17 pi over 12 as either the sum or difference of two others that we might know. Okay, well, to think about, if I need the denominator to eventually be 12, I know it could be pi over 4 and a pi over 3, because together those denominators would definitely make 12. So let's think, and all I'm going to do is try to pick up two that I know. Let's see, like maybe 3 pi over 4 and 2 pi over 3. There's definitely two that I know. And if we want to check just to make sure it does, let's come down here for just a second. 3 pi over 4 plus 2 pi over 3. And if we get a common denominator, like I said, of 12, see, 4 times 3, so 3 times 3 is 9. Let's see, 3 times 4, so 2 times 4 is 8. And 9 and 8 is 17 pi over 12. So there we go. Those two work out. And sometimes it's just a kind of like a trial and error where you're trying to pick just any two that you know. But, if these, by the way, this is not the only pairing that'll work. Some other pairings you can obviously do is pi over 6 and pi over 2, because those are definitely will add up to pi over 12 for sure. Okay? All right, so let's go through, finish expanding this out. So it's going to be cosine of the first times cosine of the second, opposite, so this time I did a sum again, so I'm going to put a minus, so sine of the first times sine of the second. Alright, all of that under 1, since we're looking technically for secant. And let's start filling in some information that I know. What is the x value at 3 pi over 4? Well, at 3 pi over 4, we're in quadrant 2, and the x value there is the square root of 2 over 2. The x value at 2 pi over 3 in quadrant 2 is negative 1/2. Okay, the y value at 3 pi over 4 is square root of 2 over 2. And the y value at 2 pi over 3 is the square root of 3 over 2. Alright, so multiplying some of these together, you get a positive square root of 2 over 4 minus, looks like the square root of 6 over 4. So I don't need quite that much of the fraction bar. Write it like that. So I have 1 over the square root of 2 minus the square root of 6 over 4. And I'm taking 1 and dividing it by a fraction, so that's the same thing as saying 4 over the square root of 2 minus the square root of 6. Well, in math it's not proper to leave radicals in the bottom, and the way to clear it out when you've got two terms down there in the denominator is to multiply by your conjugate. So 2 plus the square root of 6 over the square root of 2 plus the square root of 6. So multiplying across the top, I'll write it as 4 times the square root of 2 plus the square root of 6. And when I FOIL the bottom, the square root of 2 times the square root of 2 is 2. The outsides and insides cancel because we did conjugates here. And the square root of 6 times the square root of 6 is 6, with the minus sign in there. Alright, kind of running out of room here, but if y'all can kind of go with me here for a second. 2 minus 6 is negative 4, right? If I take this away and write a negative 4 right there, that 4 is going to cancel with that 4 right there, leaving behind just a minus sign. So I'm going to write it like this. And there's your answer. Okay. So I'm sorry there, it's running out of room, but let's go back and recap this problem for 2 seconds. Okay. You have a formula for when you're wanting to find the sum or difference of cosine. So just relating secant as 1 over cosine, that's the key. And then going ahead and doing the expansion, finding two angles that we know that work, that'll add up to our 17 pi over 12 and expanding it out. And the last thing is just when you're going through the process of just cleaning it up, so if you have radicals in the denominator, and if you have more than one term, you've got to use your conjugate to help clean it up. Okay, let's go to example 5. We want to find the fundamental solutions in radian measure for this first example here in A. Okay, so we want to solve for this. Look at my angles. One time my angle is a 3t, then a t, then a 3t, and then a t. Okay, so in both cases, the first angles match up, 3t and 3t, and then the second angles match up, t and t. Well, let's look at our cosine formula. If I have the cosine, let's just change it up. Say two angles added together, say alpha and beta. It's the cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. First angles match up, alpha and alpha. Second angles match up, beta, beta. And it goes cosine, cosine, sine, sine. Look over here, cosine, cosine, sine, sine. First angles match up, second angles match up. So we actually have our cosine expansion. If the center sign's a minus, that means it's going to come together as a sum. So it's the cosine of the first angle plus the second angle equals 1. Okay, so take 2 seconds and look. If you started here at this and I wanted you to expand it, would you go right back up to the top? Cosine of the first, cosine of the second, minus sine of the first, sine of the second. So it's looking good. And combining these together, it's saying cosine of 4t equals 1. And this is referenced right back to our last lesson. Is anytime your angle has a coefficient with it, you can never leave that you have to leave that coefficient there. You can never divide it off. So what that's referring to is how many rotations. So for 4 rotations, we want x value equal to 1, and our answers need to be in radians. Okay, so 4t is equal to, when do I have an x value of 1? Well, the x value of 1 happens only at 0 pi, or 0, and then at 2 pi, and then at 4 pi. So 1 rotation, 4 pi. Sometimes you can consider the 2 pi but as the start of the second one, but we're going to consider it kind of all in one. 4 pi comes from the second rotation. 6 pi is the third rotation, and then 8 pi. Alright, all we have to do to finish this up is divide everything through by 4. So 0 divided by 4 is still 0. 2 divided by 4 will be pi over 2. 4 divided by 4 is pi. 6 divided by 4 and reduced it will be 3 pi over 2. And 8 divided by 4 is 2 pi. And there are all your answers again. Okay? So every rotation, basically, there was only one value for every rotation because there's only one spot where you have an x value equal to positive 1. Over there at pi and 3 pi and 5 pi, that's actually when cosine equals negative 1.